Hi, in the previous video, I asked you to think about this question. Can you calculate the joint probability when you have an additional information? The answer is yes, because we can set up the problem in the same way. We have four unknown variables, x, y, z, w, and the information we have can be written as this way: x plus y, probability of not having an health insurance is 30.69%, which is a marginal distribution. And x plus z, the probability of female is 50.52%, also another marginal distribution. And y, the probability of man without health insurance was 19.89%. Then from these three equations, can we solve for four unknowns? Excuse me. The answer is no, but we need additional equation, and that is already given implicitly. That is the basic property of probability. When we formulate the problem in this way, we implicitly assume that this is a probability distribution table. So any probability distribution table has to satisfy that all the probabilities sum to always 100%. Some of the probabilities must be always 100%. It's obvious. It's clear. So we additionally have information given by this equation: x, y, z, w sum to 100%. Now we have four equations, and using these four equations, we should be able to solve for four unknowns. It is pure algebra, pure mathematics algebra, and I will so here in this case it is case by case. So in this problem, we can solve for the unknowns in this way. Number 3 gives us what the exact number for y, and we know y. So in equation 1, we know y, so we can recover x by taking this value. So if x is this number, 33.69 minus y, and we know y, so we can calculate x. And z, now we know x, so in the second equation we know x, so we can trace out z. So we know z equals to this number. And in the final equation, we calculated y at z, so w is the remainder out of 100%. So we have w from the last equation. So in this way, by this test, we can calculate, we can solve for the unknowns. But this is not the only way. You may use different steps, and you may use different methods. I'm just showing you an example, one possible way. And there is no general way, most general way to solve for a system of linear equations is to use matrix. But to use matrix, you have to learn matrix algebra. So that's more costly than solving for an equation like this. And usually when you have this kind of equation, you have to try to cancel out a variable, or like recover one by one. So there are several techniques, and I believe you know how to do that. You should be able to know how to do that. And if you have questions, if you have difficulties, you may ask questions to me in the office hours. I can demonstrate how to do it again. And I would like to, and later we are going to have more algebra. So I want you to show you my handwriting. So I bought a stylus, but I hoped it works on my desktop, but somehow it does not work. I think it is connect the Bluetooth. My desktop does not have Bluetooth connector. I don't know what it is. Anyhow, it my desktop cannot detect this device. So then I may either have to buy another one for desktop, or I may try this on my iPad, and I will see how it works. And later, when needed, I will try to show you my handwriting of my algebra. So that may help. I think that's the biggest difference between classroom teaching and online teaching. I want to have a tablet like on my desktop to show you the step-by-step algebra. Anyhow, if you have any good idea, if you have a good recommendation of a product, a stylus, or a program, or anything that may be useful and inexpensive, should be inexpensive, please let me know. I'm looking for something to use when I demonstrate algebra. Anyhow, try this algebra by yourself. So try this algebra by yourself, and if you struggle, let me know. I can help you. And so finally, so we just solved for x, y, z, w. Then if you fill these numbers back into the joint probability distribution table, you have all the numbers in the table. So it's easy to see the probability you want is this. And the point here is the last information, this additional information helped. And simply speaking, it does not matter what this information is about, but it should be about both variables. So additionally, y is given, but it doesn't need to be y. If it was about w, then still you would be able to solve the problem. So what we need is information about two variables at the same time. So in this case, y was the probability of men without health insurance. So it is about gender and health insurance at the same time. So we need some information that contain both variables. So that was kind of intuition. And what's missing in the marginal probability distributions is the relationship, the association, correlation between two variables, which is complemented by this guy. That was the conclusion of this problem. And so what I'm telling you is there are joint probability distribution and marginal probability distribution. And simply speaking, joint distribution is everything. It contains the full information, but marginal distributions don't. But marginal distributions are easier to understand and easier to present, easier to find from data set. So still marginal distributions are useful in some cases, but be careful. Okay, this is it. Thank you for watching the videos. The second part of the second part of this chapter, so class, the third class, was a little bit short. I think it's about slightly over 30 minutes or 40 minutes. But that's just my failure of balancing, splitting the materials. I had to stop somewhere earlier in the second class, but I couldn't. It's good or bad because in the classroom, I have to stop when the alarm rings. I set an alarm at the end of the class, at the end time of the class, and I stop no matter what happens at that time. So sometimes I had to stop in the middle of an important topic, but still I have to stop in the classroom. But online, I have no limit. I have no restrictions. I can go forever from now. I can finish all the chapters today in one video, uh, theoretically. But it's also nice that I could finish certain important topics that are related to each other. So please understand, and it is flexible. You can watch the video whenever you want. So I would not mind that much about splitting videos equally across classes and across weeks. And if you have any suggestions or any comments, also feel free to send me an email. And see you tomorrow. Like now, I'm recording this video on Monday night. I will see you tomorrow in the office hour. Bye.